Okay, so, as I mentioned, this is one case where you can't reason out with this diagram. Let's just see why it is. It's because delta S is here, A is here, and delta T is here. Okay, well, delta T is connected to delta S, and delta T is connected to A, but A isn't connected to anything else that's connected to what delta S is. At least nothing we can find if we know A, delta T, and delta S. So if you think about it, you find that there's no connection you can make. You can't complete a triangle between A and delta S. There's no line of reasoning that allows us to get there. And this is not too difficult to understand because velocities are related to delta S and delta T, and accelerations related to delta V, change in velocity over delta T. But if this is all we're given, we're not really given enough to connect either A or delta S with what we know about the velocities. In any case, if you try to do it, you're not going to be able to, and you got to be aware there are two cases where we know delta S and A and either V naught or VF. Okay? You can't do this with triangles, you can't do it with direct reasoning. You got to use equations, and in this case, the equation that you really want to use is the fourth equation that we derived last time, VF squared equals V naught squared plus 2A delta S. And that equation will get you through the logjam because, of course, it includes A and delta S, the two things that go together with another velocity and don't give you anything you can get by the direct definitions. And remember, this equation is derived, for example, by taking these two equations and eliminating delta T. Okay? So it's related to something you can get by direct reasoning, which is basically these equations, which are just equivalent to these definitions. But you put them together as simultaneous equations, eliminate delta T, you get this equation, and now this allows you to relate A, delta S, and V naught, and VF. If you know three of these, you can find the fourth.